this will be a kind of a shorter video today for the billions of Twitch fans out there. Thanks for the million bits, etc. Thanks for the gifted subs. Okay, 15B and 15C. I think once we look at those, if you still don't get it, I'll talk to you individually. We will sort it out. 15B. Okay. The question is, what number, if you subtract it from its own square root, gets you 2?
Is it 30?
30?
Your answer in physics is 30. 10 square root minus 5 divided by the 20th power. What?
Oh.
What?
Minus
Well,
25.
Divided by the 20.
Anyway,
You can't do it.
this question,
No.
if you got a good, what they call it, number sense, you might look at this and go, well, it's kind of strange. Don't square roots tend to be bigger than, or sorry, don't square roots tend to be smaller than their number? Like, for example, the square root of 81 is 9.
Yeah.
The square root of 100 is 10. So how are you going to square, how is this smaller value minus the value going to be equal to 2? Now, then again, it's not always true, because like the square root of, say, 1/4 is 1/2.
Oh wait, no, that doesn't make sense. I was thinking x could be a negative, because then it'd be the square root of x plus x, but you can't, what am I thinking? Square root of negative x.
No. Yeah, I hear what you're saying. So let's use that technique of graphing, the graphing technique, to say, if there's going to be a solution, what kind of number are we looking for? Big number, small number, what kind of number? And Julie already hit on a big idea, which is we have to be looking for a positive number just because of the fact that the question has square root of x in it. Okay, so take one step, because, I mean, who knows what that looks like? If you graphed y equals root x minus x, that's not really obvious what that looks like, right? But if I rearrange the equation a little bit, if I add x to both sides, I have that. Do we know what that looks like as a graph? And do we know what that looks like as a graph? Yes, we do. Let's graph it like fairly carefully. Okay, so the square root function looks like this. And then when I say carefully, I mean because you got to make sure that it's relatively proportional. So let's say that's 1, 2, 3, etc. Now what does x plus 2 look like? What does that tell us?
No.
There's no solution.
I just didn't. Me too. Nope, there's not a solution.
Good point. That's a good point. Let me quickly run through how else you could have found this. I really want to encourage you to think graphically. Look how efficient that is graphically. But let's say I'd squared both sides of this. We would have had x equals, when you square this, don't make what they call the freshman's mistake, which is to go x squared plus 4. You have this, and then if you solve that, so you had Zarita?
Yes.
And then if you quadratic formula that, so remember quadratic formula is going to be, if your equation is a times x squared plus b times x plus c equals 0, then your solutions are negative b plus or minus the square root b squared minus 4ac all to a. So, but you might be noticing already, like, wait a second, that's weird. The number under the square root is going to be b squared, 9, minus 4 times 1 times 4. But 9 minus 16 is negative, and you can't square root that. Although this is how you take the approach. If you were going to look for, say, an imaginary or what they call a complex solution to this, a non-real solution, then this is the route you'd want to take. Okay, so everyone is fine with how this is the answer?
I don't know, I like mine. This
What?
answer is pretty good.
Oh, okay. This is a valid justification for the answer no solution. The graph is valid. Okay, you don't have to. if you graph it to start off with and you see that the graphs never cross, you can conclude there's no solution without showing the algebra leads you to a non-real quadratic solution. So one more. C looks like this. Square root of x. I already forgot what it said. All right. Do a quick sketch of the graph of that. And what I want to know is what kind, well, first, how many solutions are there? And what kind of, spoiler alert, it's one. There's one solution. What kind of number are we looking for? Okay, that's true, positive. I can tell that just by looking at this, though. That if there is a solution, it's got to be positive. I can't square root a negative number. There's your square root graph. So I graph the left side. And then graph the right side. I'll give you a hint. The answer is bigger than
4.
3.
I was looking for 3. I think it is bigger than 4 and probably 5.
Yeah.
But I was just saying 100% sure that this number is what? What's that number?
3.
3. So I'm 1,000% sure that the answer is bigger than 3. And I'm sure you're right. I'm sure it is bigger than 4 and bigger than 5. But, this will be the distinction that gets us the answer. Okay, square both sides. Square root of root x is x. Square root of x minus, or sorry, did I say that wrong? Square root of x squared is x. X minus 3 squared is x squared minus 6x plus 9. We're all fine with that, right? Good. Okay. Now what?
No. Subtract the x.
Subtract x from both sides. Very good. You might ask yourself for a moment or two, is that factorable? You're going to figure out pretty quickly most of the time that no, you can't factor that. We got to use, you can complete the square if you really want to, but when this number here is odd, it's usually easier to use quadratic formula. So the opposite of b is -7, so the opposite of b is 7, plus or minus the square root of 49 minus 4 times a times c. So that dude there is going to be 36 all over 2 times a. So 49 minus 36 is 13. Now the question is it 7 minus root 13 over 2 or 7 plus root 13 over 2? Yeah. So it's probably not, I would imagine it's probably not obvious to most of you guys immediately that 7 minus root 13 over 2 is less than 3. So you probably have to think about that for a second. But like, if you go 7 minus root 13, what kind of number is that? Well, this is approximately what? Very roughly.
4.
3-ish, 4-ish. It's between 3 and 4, right? So 7 minus this number is going to be 3 and change, right? 3 point something. Divide that by 2, you got 1 point something. So clearly it's less than 3. So anyway, the graph tells us that it's got to be 7 plus 3. Okay. The last thing I want to discuss here is, this is especially for those of you that say, this is easy, I got this. This is a deeper question, a more challenging question. How come our algebra, if our algebra is so good, which hopefully it is, if our algebra is valid, how come it produced 2 answers, right? When there's really only one answer.
Because we squared it?
It's lit. Good job. That's exactly correct. It's this step right here. When you square something, like notice like the original equation has only one solution, as you can see. But when you squared it, you turned it into a quadratic with two solutions. So why is that? Why does squaring both sides produce a wrong solution, or as they say, extraneous solution? Huh? Yeah, basically, yeah. I was gonna say like, well, yes and no, because the 7 minus root 13 over 2 wasn't a negative, but it kind of ties into that. Here's what I'm getting at. Squaring both sides of an equation can take a false statement and turn it true. I'll give you a really simple example of that. True or false, guys? 4 equals negative 4. That's a false statement, right? But if I square both sides, I turn it into a true statement. So that's what's going on there with like 7 minus root 13 over 2. If you plug 7 minus root 13 over 2 into this equation, it's a false statement. But if you square both sides, it's a true statement, just like this. So anyway, if you were wondering, where does that come from? It's when you square both sides of an equation, you got to be careful because that can tend to introduce solutions that aren't actually solutions to the original thing you started off with. All right, that's it for my talking today. You guys can take this class time to work on your assignment.